Good morning, everyone. In the last session, we started our discussion related to data JPA. Data JPA is used to develop persistence logic in our application. So what is persistence logic? The logic which is responsible to communicate with the database is called as persistence logic. Already we have JDBC, Spring JDBC, Hibernate, Spring ORM to develop persistence logic. If we use JDBC or Spring JDBC or Hibernate or Spring ORM, we should write some common logics in all the DAO classes to perform CRUD operations. If you go for data JPA, you no need to write the common logics to perform the CRUD operations because data JPA provided predefined repository interfaces, right? So what are the repository interfaces available? We have CRUD repository and we have JPA repository. In the CRUD repository, we have just methods to perform only CRUD operations like insert, update, and delete. Whereas if you go for JPA repository, we have methods to perform CRUD operations along with pagination, sorting, and query by example. Right. Hibernate versus JPA. Hibernate, if you use Hibernate, that is a ORM framework to develop the persistence logic, you need to write the methods in all the DAO classes. For every table, one DAO class will be created. So in every DAO, we need to write the methods to perform the CRUD operations. Whereas if you go for data JPA, it will provide the methods to perform the CRUD operations. You no need to write the logic to perform the CRUD operations. It will provide the methods to perform CRUD operations for you. That means, so with zero methods, we can perform the CRUD operations in our application by using JPA repository, right? Now, so today we are going to work with our JPA example. So in order to work with JPA example, first we need to have our environment setup. So environment setup, that means I'm going to use MySQL database here. So in order to communicate with MySQL database, so I'm using MySQL Workbench. MySQL Workbench is a client software. So in this Workbench, I'm going to create the tables. I'm going to write the queries so that tables can be created, queries can be executed. Workbench is just a client software and a database is a server software. So what will happen is first we need to install one database. First we need to install one database. You can install either MySQL or Oracle or Postgres. So here I'm installing MySQL database. MySQL database, right? So MySQL server, that means it is a database, MySQL DB server, where our data will be stored. How to check whether data is stored or not? How to write the queries? In order to do that, here we are going to use client software. It is called as Workbench. MySQL Workbench I am using. I'm using MySQL Workbench. Okay. So what is the difference between database server and MySQL Workbench? MySQL Workbench is just a client which is used to communicate with a DB server. It is just a client. Workbench is going to act as a client software. Using this Workbench, we are going to communicate with the database server, right? So we are going to write the query here and it is going to interact with the database server and it is going to respond. So query and result. Here we are going to execute the query from Workbench. Query will be executed in the DB server. The DB server will send the response back to us. Are you guys clear with my point? So what is the purpose of DB server and DB client? DB server is the place where actually the data will be stored. Workbench is a client which is used to communicate with the server. Now, let me open my Workbench, MySQL Workbench. Okay. Yes, my MySQL Workbench got opened. Now, here I have the database connection. I have the database connection. Okay. So let me go here, show databases. Show databases. What are the databases available in the database? It is displaying here. There is a database called SBMS. So let me use SBMS. Let me use the database name as SBMS. Yes, SBMS used. Show tables. Show tables in the SBMS. So user table is available in the SBMS. Okay, so my table name is user. I will create a new table. So tables are currently only one table available. My database name is SBMS. Okay, so now here I'm going to note down database properties. MySQL database properties. MySQL DB properties for my local DB. So here MySQL DB host, what is the host here? It is running in the local host. And what is the port number of the database? 3306. So username and password. So whenever you install the database, it is going to ask you these details. Now I have noted down my database properties. Okay, let me get the username and password of my database. I have configured the username password in some file. Okay, yeah, so username is Ashok IT, password is Ashok IT @123. So this is my database username and this is my password, Ashok IT @123. Okay, so these are my database properties. Database properties. If you want, you can copy this. You can keep it. ORM properties. So data source properties I have noted down. So this is my MySQL driver class URL. My database name is SBMS. SBMS is the name of my database. So 3306 is the port number. Localhost, the database is running in the same machine. Wherever I am developing a Java program, in the same machine, my database is running. Then here I have JDBC MySQL localhost 3306/HBMS. So this is my data source URL, my data source username, my data source password. I'm going to connect with MySQL. So MySQL driver class is available. Auto DDL, if the table is not available, table can be created dynamically. Show SQL, whatever the queries we are executing, those queries will be printed on the console by using show SQL. So with this, can I say my environment is ready to develop the application? With this, can I say my environment is ready to develop the application? Yes. So all of you install MySQL database server and MySQL workbench. So what is the purpose of workbench? Workbench is a client which is used to communicate with the database server. You can see what are the databases available in the MySQL. In the MySQL, these are called as databases. In the Oracle, these are called as schemas. In the Oracle database, we will have a schema concept. In the MySQL, we have database concept. So here I'm using database. My database name is SBMS. I have created SBMS database. I'm using the database. I'm seeing the tables available. There is only one table is available. I will create another table to perform operations now. I have noted down my database properties. Good. Next one. We need to understand about a concept called entity class. We need to understand a concept called entity class. So guys, we are going for ORM mapping. ORM mapping means object relational mapping. Everything will be represented in the form of objects. Entity class, the Java class which is mapped with the Java class which mapped with the DB table is called as entity class. Okay, so here in our database we will have a tables. In our Java application we have objects, classes. So one Java class we need to map with the database table to perform the CRUD operations. Now, for example, so if you go here, we are going to create one Java class. So for example, I'm taking a class with a name called player. I'm taking a class with a name called player, cricket players. Let me take a class with a name called player. Inside this class, I'm going to specify some variables. Okay, integer player ID, integer player ID, then string player name, string player name, integer player age, player age. Okay, string location, string location. So like this, I'm taking one Java class called player class. Now, player class data I want to store into database table. So here, for this, we are going to create one database table called cricket players. My table name is going to be cricket players. Now, here I'm going to take player ID. I'm going to take player name, player age, location, like this. So this is my database table. This player ID, I will make it as a primary key. Player ID will be represented as a primary key. So unique data should be inserted in the player ID column, like this. This is my database table. Java class is available, database table is available. Now I want to insert one object into database table. I want to insert one object into database table. Here, if you observe, I am not taking the primitive data types. I'm taking wrapper classes. I will tell you the reason also why we are going for wrapper classes. Primitives, you can take it, but not recommended. Primitive data types, you can take it, but not recommended. I'm taking wrapper classes. Why I'm taking wrapper classes? I will justify that also. All right. Are you guys clear with this one? Are you guys clear with this one? One database table is available, one Java class is available. Currently, is there any relation between this database table and Java class? Is there any relation between this database table and the Java class? No. Now my requirement is, I will represent the data. We are using Java. Java is object-oriented programming language. Everything will be represented in the form of objects. Java is object-oriented programming language. Everything will be represented in the form of objects, right? I will represent the data in the form of object. So I want to store the object data into database table. In the JDBC, you will write a insert query. You will represent the data in the text format. But now I don't want to represent the data in the text format. I want to represent the data in the form of object. So when I call save method, I want to insert one record. Are we writing the queries in the JPA or we are not writing the queries in the JPA? Guys, are we going to write the queries in the JPA or we are going to use the JPA repositories? Are we going to write the queries or we are going to use the JPA repositories? We are not going to write the queries. We are going to just call the methods available in the JPA repository. Now, to insert a record, there is a method called save method. For example, I am going to call one method called save method, save of player object, save of player object. So save method I am using to insert one record into database table. Guys, 1 minute. Right, guys. So here I have a player class and I have a cricket players table. I want to insert the player record into database table. So here in the JDBC, we will write a insert query, but in the JPA, we are not going to write the insert query. We are just calling the save method. Save of a player object. So I am calling save of a player object, but where this player object should be inserted. Is there any relation between this class and the table? In the project, we will have multiple tables. Which object data should be stored into which database table? So do we need to have some mapping between our Java class and the database table, or we don't need to have any mapping between the Java class and database table? I will have a employee class. I will have a I will have a user class. I will have a book class. I will have a product class. Which record should be, which object data should be stored into which database table? In our Java project, multiple classes will be available. In the database, multiple tables will be available. So here, in order to insert the record in the form of object, there should be some mapping between our Java class and the database table. So now here, player is a class. Player class will be mapped to cricket players table. Player ID variable will be mapped to player ID column. Player name variable will be mapped to player name column. Player age variable will be mapped to this player age variable column. Location variable will be mapped to location column in the table. Are you guys understanding why we need to establish mapping between our Java class and the database table? Why we need to establish the mapping between Java class and database table? In our project, multiple classes will be available. In the database, multiple tables will be available. When I call a save method with one object as a parameter, this JPA should understand which record should be inserted into which table. We need to create mapping between Java class and database table. We need to establish mapping between, we need to establish mapping between Java class and DB table. So we will use annotations. Using annotations, we can map. Using annotations, we can map. So here we are going to use annotations @entity, @table, @id, column. So these are the 5 annotations that we are going to use in order to establish the relation between our Java class and the database table. We are going to establish the relation between the Java class and the table by using annotations. If any Java class is mapped with database table, then that Java class is called as entity class. So when we are working with data JPA, we need to create entity classes. What is a entity class? What is a entity class? The Java class, which is mapped with the DB table, is called as entity class. To map Java class with the DB table, to map Java class with a DB table, we will use below annotations. Okay, what are the annotations? @entity, it represents our class as entity class, eligible for DB operations. It represents our class as a entity class. What is this? @table, it represents class name mapping with the table name. It represents to map our class with table name. It represents our class with table name. So here, if we don't use @table is optional annotation. @table is optional. @table is optional if our class name and table name is same. So if your class name and table name both are same, then you no need to use @table. Suppose here in our scenario, what is my class name? My class name is player. But what is my table name? The table name is cricket players. cricket players. So for that, there is a difference. Class name and table name both are different. When the class name and both table name and both are different, in order to create the mapping between the class name and table name, we will give at the rate table annotation, right? At the rate entity is one annotation. It represents our class as entity class. At the rate table, it represents to map our, it is used to map our class with table name. At the rate table is option. It is mandatory and entity is mandatory. It is a mandatory annotation. Without this, you can't do anything. It is a mandatory annotation. At the rate entity is a mandatory annotation. At the rate table, use it to map the class name with the table name. It is optional annotation. If a class name and table name both are same, then you no need to give that. Next one, at the rate ID. At the rate ID, it represents variable mapping with a primary key column in table. So which variable is mapped with the primary key column in the table? For that variable, we are going to use one annotation called at the rate ID. At the rate ID represents variable mapping with the primary key column in the table. It is also mandatory. It is mandatory annotation. So every table should have at least one primary key. So when the table is having one primary key, then which variable is mapped with the primary key, that variable will be represented as a ID variable at the rate ID. At the rate ID represents this variable is mapping with the primary key column. Next one, at the rate column annotation. At the rate column, it is used to map our class variables with table columns. It is used to map our class variables with DB table column names. DB table column names, right? At the rate column is optional if variable name and column name both are same. At the rate column, is optional if class variable name and DB table column names are same. DB table column names are same. So these are the 5 annotations we are going to use to write one entity class. So the Java class, which is mapped with the DB table, is called as an entity class. So if you have 100 tables in the database, then you need to create 100 entity class. For every database table, one entity class we are going to create, and we are going to map the class with the database table. It is mandatory. When you go for Hibernate also, when you go for Spring ORM, when you go for Data JPA, entity classes are mandatory. So what is entity class? The Java class which is mapped with the DB table is called as entity class. The Java class which is mapped with the DB table is called as entity class. How we are going to map the Java class with the DB table? In order to map Java class with the DB table, we have few annotations. At the rate entity, at the rate table, at the rate ID, at the rate column. What is the purpose of at the rate entity? Entity represents our class as a entity class. That means it is eligible for DB operations. It represents our class as entity class. Entity class. What is the meaning of entity? It means it is eligible for DB operations. What is at the rate table? Table annotation is used to map our class name, our class with the table name, our class with the DB table name. Suppose for example, your class name and table name both are same, then you no need to specify that. So here, to map the class name with the table name, we are going to use one annotation called at the rate table. So here, if you want to represent this class as the entity, at the rate entity annotation. So at the rate entity is a mandatory annotation which is used to represent our Java class with as an entity class. So here, how to establish the mapping between the class name and the table name? At the rate table annotation to map our class name to the table name. Entity is mandatory, but a table is optional. When the table is optional, if you don't use the table name, it will consider class name as a table name. It will consider the class name as a table name. If our class name and table name is same, if we don't give table, if we don't give at the rate table, then it will consider class name as table name. It is going to consider class name as a table name. Sometimes the people will not write at the rate table. Then what the JPA will understand? If the table is annotation, if the table annotation not available, it will consider our class name as table name. Then what is ID? ID represents, it represents variable mapping with the primary key column in the table. So every table will have at least one primary key. So to map the class variables with the primary keys, we will go for ID. ID is a mandatory annotation. Next one is column annotation. What is column? Column is optional annotation. If class variable name and DB table name, DB table column names are same. If we don't give at the rate column, then it will consider variable name as a column name. Variable name as column name. Are you guys clear with my point? Column is optional. If variable name and table column names are same, if we don't give column, then it will consider variable name as column name. Are you guys clear with this? What is entity class? What is entity class? Yep. Why we need to create this entity class? Why we need to map this class with the table? Why entity classes are required? Here, we are not writing the queries to insert the records. We are going to call the methods of JPA. We are going to use the methods of JPA. So in our class, in our project, so many classes will be available. In database, so many tables will be available. Which record, which class data should be inserted to which table, that mapping we are doing by using entity class. Yes, can you look at this diagram? Is it clear, guys? What is mapping? Why we are doing mapping? Is it clear why we are doing mapping? So database will have multiple tables. Database will have multiple tables. Project will have multiple classes. Which class object data should be stored into which table will be represented by entity class. Okay. Now here, note, for every table, we should create one entity class. For every table, we should create one entity class. So this entity class represents data. DB operations should be performed in which table? DB operations should be performed in which table? Entity class represents DB operations should be performed in which table? So I hope you guys are clear with what is entity class. Are you guys clear with entity class? Yep. Could you please read these points once? Could you please read these points once? Please read it. The Java class which is mapped with the DB class is called as entity class. To map Java class with the DB table, we will use below annotations: @entity, @table, @ID, @column. Entity is used to represent our class as an entity class. Table is used to map our class name with the DB table name. Table is optional. If you don't give table, then it will consider the class name as a table name. ID is representing primary key column. Column is used to map our variable name with the DB column name. If you don't give column, it will consider the variable name as a column name. Good. Next one. So if you have 1,000 tables, then you need to create 1,000 entity classes. If you have 1,000 tables, then you need to create 1,000 entity classes. One entity class will be mapped with only one table. One entity class will be mapped with only one table. one entity class will be mapped with only one DB table. Sir, can I map one class with multiple tables? It's not possible. One entity class will be mapped with only one table. If you have 1000 entity classes, then that means 1000 tables are available. If you have 500 tables in the project, then you need to create 500 entity classes for that. Okay. Next one, repository interfaces. Repository interfaces. We need to create user defined interface to perform our CRUD operations. JPA provided repository interfaces. JPA provided repository interfaces to perform CRUD operations. We need to create our repository interfaces. For every table, we will create one repository interface. For every DB table, we will create one repository interface by extending JPA repositories. Here, I don't want to write the methods to perform the operations. JPA already provided the repository interface, like CRUD repository is available, JPA repository is available. CRUD repository is available, JPA repository is available. So here, in order to perform the CRUD operations, we no need to create the methods to perform the DB operations. JPA already provided the interfaces. So what we do is, we are just going to create one interface by extending the properties from JPA. For example, we have players object, right? So what I will do is public interface player repository extends CRUD repository. Player repository extends CRUD repository. Like this, I'm going to create one repository interface. That's it. Now here, CRUD repository should perform operations to which table? In my project, multiple tables will be available. So for every table, we are going to create one repository. For every DB table, we'll create one repository interface by extending JPA repositories, from JPA repository. So now I want to perform the operations in the cricket players table. For cricket players table, already one entity class is created. The Java class which is mapped with the DB table is called as entity class. Now, along with the entity, we need to create one repository. So to call the methods, right? Now, here I am extending the properties from CRUD repository. So this CRUD repository should use which entity? So when I call save method by using CRUD repository, in which table it has to perform the operation? Here, we need to specify entity class name. We need to specify entity class name, entity class, and we need to specify primary key data type. That's it. So if you just to create one repository interface like this, then you can perform the CRUD operations, because our repository is not a normal repository. Our repository is extending the properties from CRUD repository. Our repository is not a normal repository. Our repository is extending from CRUD repository. Note, when our interface extending properties, when our interface extending properties from JPA repository interfaces, then JPA will provide implementation for our interface in runtime using proxy design pattern. Guys, here, are we going to implement our interface, or JPA will implement our interface? Are we going to implement our interface? JPA is going to implement our interface. Are we going to implement our interface, or JPA is going to implement our interface? JPA will implement our interface. You no need to write a single method also. You just need to create one interface. Public interface player repository extends from CRUD repository. So CRUD repository we are extending. That means this CRUD repository will provide the methods for us. Save method, delete method, retrieve method, whatever the method, whatever the CRUD operations you want to perform, for all your CRUD operations, you will get the methods from the CRUD repository. So in order to call the CRUD repository methods, we are creating one dummy repository and extending the properties from that. So whenever we are extending the properties from the CRUD repository or JPA repository, you can do either you can do the extending from CRUD repository, or you can do the extending from JPA repository also. Two repositories are available. If you go for CRUD repository, you have few methods to perform CRUD operations. You have few methods to perform CRUD operations when you go for CRUD repository. If you want more functionality, like I want to implement pagination, I want to implement searching, I want to go for query by example, then in that scenario, your repository should extend the properties from JPA. You can extend the properties from CRUD repository, or you can extend the properties from JPA repository. CRUD repository having only few methods, JPA repository having more methods. So when you compare CRUD repository and JPA repository, you will have more functionality. You will get more features with the JPA repository. So it depends upon the requirement. If you want to go with only just CRUD operations, then go with the CRUD repository. If you want more features, then go with JPA repository. Okay, here, if you want to develop the persistence logic by using data JPA, these are the two things we are going to do. One is entity class we are going to create. Entity class we are going to create public class player, public class player class. So inside the player class, I'm going to write the variables private integer player ID, and I'm going to write private string player name, private integer player age, private integer player age, and I'm going to specify private string location. Okay, so how to represent this class as an entity by using @entity? How to map this class with a table? Table name is equal to cricket players. Cricket players. Now this is a primary key column variable @id. How to map it with a column? @column name is equal to player underscore id. Player underscore id. So the remaining variables also I am going to map with my database columns. Player name I am mapping with player underscore name column. Name column. Player age I am going to map with player underscore age variable. Player location I am going to map this with location variable. Location variable will be mapped with the location column, but actually variable name and column names are same. Then you no need to give the column annotation. You no need to give the column annotation. Generated value I will tell you later. When I talk about primary keys, I will tell you what is generated value. Okay, Mr. Tota, I will discuss about generated value in the coming classes. Guys, are you clear with this? What is entity and how to create an entity class? Are you clear with what is entity? How to create entity class? Entity class means just a Java class which is mapped with the DB table to perform operations. Right. Next one. Are you clear with what is repository interface? Are you clear with what is repository interface? So for every table, one entity will be available, one repository will be available. So repositories are used to perform our CRUD operations. Repositories are used to perform our CRUD operations. JPA provided repository interfaces to perform the CRUD operations. For every DB table, we will create one repository interface by extending the properties from JPA repositories, either CRUD repository or JPA repository you can use. So public interface player repository extending from the CRUD repository. Entity object. So what is our entity object here? Player. So you can specify player is your entity class. Entity class we are going to specify ID. What is the primary key data type? Integer. What is the primary key data type? Integer. So this is syntax. This is syntax to create a repository. Okay, here we are going to specify entity class and we are going to specify data type of that primary key. It is a ID. So this one I will consider this as a example. I will consider this as a example. So I'm creating player repository by extending from CRUD repository or by extending from JPA repository. Then here we are going to specify our entity class. Here we are going to specify data type, primary key data type. Either you can specify integer, or if you want to specify a generic type, you can go for serializable also, no problem. You can go for serializable or you can go for integer, anything is fine. Okay, now here guys, this data JPA is a special interface, JPA repository or CRUD repository special interface. When you create a interface by extending from the CRUD repository, JPA will provide the implementation for our interface in the runtime. We no need to implement our interfaces. JPA will implement our interfaces in the runtime. So that is their internal logic. They are using proxy design pattern to create the implementation classes for our interfaces. You no need to implement it. Your logic is done. If you want to perform the CRUD operations for one table, you just create one entity, you create one repository, that's it. Kel katam dukan band. You no need to do anything else. The rest of story will be taken care by data JPA. The rest of story will be taken care by data JPA. So it is going to provide the implementation for your interface in the runtime. When it will provide the implementation for our interface, if our interface is extending the properties from the CRUD repository, then it is going to provide the implementation for our interface. Are you guys clear with my point? Are you guys clear with my point? Yes. So in order to develop a data JPA application, what are the things we need to create? In order to develop data JPA application, what are the things we can create? What are the things that we need to create? What are the things we need to create? One is entity class and the second one is repository interface. Entity is a class, repository is an interface. Can you tell me what is the purpose of entity class and repository interface? Can you tell me what is the purpose of entity class and repository interface? Come on. What is the purpose of entity class and repository interface? Entity class is used for table to DB mapping, table to class mapping. Why repository interface? Entity class is used for mapping, class name mapping, class mapping with the table. Why repository? Entity purpose is clear, but why repository interface we need to create? We are creating just a dummy repository interface, right? We are not writing any methods. Why we are creating this empty interface? To call the JPA methods. Why we are creating an interface by extending from CRUD repository? To call the methods which they provided. So to perform the methods they provided, some methods like inserting, there is a method. For retrieving, there is a method. For updating, there is a method. For deleting, there is a method. So they provided predefined methods. In order to call their methods, we are extending their interfaces. We are extending their interfaces. Okay. Next one, data source properties. Data source properties. What is the meaning of data source properties? Data source properties represents with which database we want to connect. Database details. Data source properties represents with which database we want to connect. With which database we want to connect. So we need to configure database properties. Data source properties represents with which database we want to connect, like DB URL, DB driver class, DB URL, What is the URL of your database? Where is your database? What is your username of the database? What is your password of the database? What is your driver class name? DB driver class. So these data source properties we need to configure. Now like this we are going to configure data source properties. So we will configure the data source properties. We will configure data source properties in application.properties file. Application properties file or application.yml file. In future, we are going to work with application.yml. Currently, we are going with only application.properties. Now, can you see how I am going to configure my data source properties? Spring.datasource.url, jdbc colon, mysql colon, localhost colon, 3306/sbms. Guys, I am using MySQL database. You can use Oracle database also. If you are using Oracle database, then configure Oracle data source properties. I am using MySQL, so I am configuring MySQL database. Okay, good. Data source properties represents with which database we want to connect. Next one, here there is another concept called ORM properties. There are some ORM properties. ORM properties are used to, ORM properties we will use to get the benefit of ORM framework. Okay, so ORM properties, additional ORM frameworks, Hibernate provided some additional benefits, while developing persistence layer, while developing persistence logic. We can create tables dynamically. Tables can be created dynamically. Tables can be created dynamically. Tables can be created dynamically by using auto DDL property. What is the property, guys? By using auto DDL property. It is called as one ORM property. So I want to develop my application. I want to run my application. Actually, my class is mapped with the database table, but in the DB, this table is not available. When I run my program, if the table is available, insert the record. If the table is not available, create the table and insert the record. So if you want the tables to be created dynamically, then we can go for auto DDL property. Auto DDL is going to create the tables if they are not available. Okay. Now we are calling JPA methods. We are calling JPA methods to perform DB operations. Right? We are calling JPA methods to perform DB operations. But what about queries? Are we going to write the query or we are not going to write the query? Guys, in order to perform these operations, are we going to write the queries or we are not going to write the queries? Come on. Are we going to write the query or we are not going to write the query? No, we are not going to write the query. But I want to see how the query got generated, how they created a query. What is the query they are executing? We are calling JPA methods to perform DB operations. So those methods will perform, those methods will generate queries to execute. To print those queries on console, we can use show SQL property. Are you guys getting my point? One is auto DDL property, another one is show SQL property. So what is the meaning of auto DDL? Auto DDL is used to create the tables dynamically. What is the purpose of show SQL? Show SQL is used to print queries on the console. So like this, if you see here, I am having data source properties to which database we want to connect the data source properties available. And I have given DDL auto DDL property, and I have given show SQL. Show SQL property is used to print queries on the console. We are going to call save method. to insert a record. Internally, it will prepare a insert query to insert that record. What is that insert query it prepared? I want to print that insert query on the console. For that, we are going for show SQL property. Show SQL property is used to print queries on the console. Next one, DDL auto. DDL auto is used to update the tables. If the table is not available, the table can be created dynamically. So these two are called as ORM properties, and these four are called as data source properties. Are you guys clear with my point? What is the difference between data source properties and ORM properties? Tell me why we are going for data source properties, why we are going for ORM properties, why we are going for data source properties, why we are going for ORM properties. Guys, come on. What is the difference between data source properties and ORM properties? Data source properties represents with which database we want to connect. ORM properties are for additional features like table creation dynamically, queries printing and all. Okay? Good. Fine guys. So thank you. With this, I'm stopping for today. So we'll continue tomorrow. Tomorrow we'll develop our first application by using JPA. Thank you.